Okay, so now we're going to relate the equilibrium constant to acids and bases. All right, and this starts on page 504. All right, so the first thing I want to talk about is the pH of a solution. Now, I think that all of you have probably learned pH throughout other science classes, but so the pH of a solution, pH, okay, it depends on two things. All right, so the first one is the concentration of the acid. Okay, second is the equilibrium constant. Between the acid and water. Acid and water. Those determine the pH. Okay, so how much of the acid is in the solution, and then the equilibrium constant between the acid and the water. How fast does the acid react with the water? Okay, so those are the two things that the pH depends on. Okay, so the equilibrium constant, how do we calculate that? Well, we just learned how to calculate that in a regular equilibrium reaction. And so it follows the same exact rules when you're reacting an acid with a water. Okay, so we don't need to learn anything new with that. What we need to do is learn the relationship between the acid and the water. Okay, so the equilibrium constant we know. And so when you're talking about an acid, the equilibrium constant of an acid with water is actually called the acid ionization constant. Okay, all that is the equilibrium constant between an acid and a water. Okay, so because we know that, we have well, let me give you an example. So if we have, they give this example on page 505. Okay, so if we have hydrobromic acid, it said, okay, so we need to determine the acid ionization constant equation. How would we make this relation between hydrobromic acid and water? Okay, so the way that you would write this, and you have to be able to build it from here on your test. You will be given an acid like this, and it will say, you know, it's going to ask you to be able to write the equation for the acid ionization constant. So what it is you have aqueous hydrobromic acid. Okay, you're going to react it with water. That's the definition of the acid ionization constant. The water is liquid. Okay, and so you remember the one, because it is the equilibrium constant, we are not going to account for water in our rate constant, right? Because it's a liquid. Okay, so what happens with an acid is it donates a proton. That's the definition of an acid. So we're going to end up with a hydronium, and every time you do an acid reacting with water, you're going to end up with a hydronium. That's going to be a product 100% of the time. It's the definition of an acid reacting with water. Okay, and then so you're going to have a hydronium, and then you have plus some BRs floating around in there. Those are also aqueous. Okay, we are balanced. So there's our equation that I wrote too big and couldn't fit it all in one line. So if we were to write an expression for the acid ionization constant, what we're looking at is the products, the concentration of hydronium plus at equilibrium times the concentration of the bromide at equilibrium, divided by, we don't account for the water because it's liquid, divided by the concentration of HBr at equilibrium. Okay, that is how we express the acid ionization constant of hydrobromic acid when it reacts with water. Okay, now what makes this a strong acid? Okay, if it's a strong acid, then that means it's going to really favor the products. Okay, so what that tells us is the larger Ka, okay, larger Ka means a stronger acid. Okay, so if we have a smaller Ka, what that means is there's a higher concentration of the initial acid, so it is not reacting as quickly. And so that means it's going to be a weaker acid. So when you're making this relationship, all right, now, when I say larger and smaller Ka, it could be, you know, a Ka of 1 times 10 to the minus 8 versus 1 times 10 to the minus 6, right? So if you're looking at these two, 1 times 10 to the minus 6 would be a larger Ka, right? Because it has fewer decimal places over. So 1 times 10 to the minus 6 would be a stronger acid than an acid with this Ka. All right, so the larger the Ka, which means the smaller the exponent, the smaller the negative exponent, the larger the Ka, the stronger the acid, okay? And also what it means is larger Ka equals lower pH. Okay, that can be shown to you, illustrated to you mathematically, but I'm not going to get into that because that's logs and that's stuff that you'll do in math. Some of you may be doing that in math. Some of you may not have even done that in math yet, but that isn't something that we're doing in. We don't need to calculate this. We need to know the general relationship. So a larger Ka means a stronger acid. A smaller Ka means a weaker acid. And so a larger Ka also means it's a lower pH. The lower pH equals a stronger acid. Okay, and so then, so as I'm talking to you about the relationship with the pH and acid, it's the opposite with the base. So a higher pH above 7, right? A higher pH when it's above 7 means a stronger base. All right, and so what that means is for a base, the smaller Ka equals a stronger base. All right, so smaller Ka, so the greater the minus sign in front of the exponent for 10. Okay, so those are the general relationships between the acids and the bases and the equilibrium constant. Okay, so relating that, like I said, if you have a larger Ka, you're going to have a lower pH. If you have a lower pH, you have a stronger acid. You need to be familiar with these relationships. This is something that you just need to remember the relationship. It doesn't require any math. Even if you're given numbers, you will be given numbers, but if you're given numbers, just know that if it's a larger Ka, meaning if they're both negative exponents, it would be the smaller negative exponent, would be a lower pH, okay? And a lower pH means that it's a stronger acid. So if you're given different acids with different Kas, and you're asked what's the weakest acid, if you're looking for the weakest acid, then you're going to look for the larger, or for the smaller Ka. Okay, smaller Ka would be, a 10 to the minus 9 versus 10 to the minus 7, something like that. Okay, so that is a relationship that you need to be familiar with. And so, yeah, so just know the relationship between pH and Ka and the stronger acid, weaker acid, that relationship of pH and Ka. So I'm going to end this video, and I might do another shorter one just to show you a shortcut, but I think this may cover it, and that completes this chapter.